audio. It as well. I'll save it on YouTube and I'll post it on today's date. So in case you miss something, it's going to be there for you as well. So let me go back to sharing screen and I'm going to switch over to my iPad. And we got there. Okay, so there's Annie. So that's good. We do this. Okay, yeah, so this switched over. Okay, so this is there. So let me see if I can see Annie. Okay, Annie, welcome. So
Thank you.
So you all set to start? Kind of
I am.
throwing you in the mix here.
I have a little hard time logging into the meeting, but I got it finally.
Okay, if you ever have problems, just text me on the phone number because I just checked because I was afraid that someone would have difficulty doing that. So let me just see. Yeah. Okay, so that's okay. So Annie, tell me, I'm gonna just stop for a second what I'm doing and ask you a couple of questions. So what are you teaching right now?
Well, I am just doing pre-K. I am a
Okay.
childcare provider and enrolled in a partnership with MSTE doing pre-K from a home environment.
Okay, and is this your first course at Notre Dame or have you taken other ones?
No, I have taken courses before. I have a BA that I got from last year, Notre Dame, and now I'm doing my master's and trying to do my teaching certification.
Okay, very good, very good. And so do you ultimately want to teach some math stuff in the grade school area or beyond? What's your thought?
Well, my goal is just to be able to do math for the little ones for pre-K or kindergarten.
Okay, sounds good. So what we're doing right now, the screen that you're seeing are the notes that I posted. So I went over the syllabus and we talked about the papers that you have. So just read that. If something doesn't make sense, just shoot me an email or a text message. Okay, and I'll help you with that. Or maybe at the end we can go over it. So what we're going to do now is I'm going to go through the chapter 1 material and we're going to discuss it a little bit and then we'll probably break up into groups and do some problems from the textbook or from another worksheet, 2 worksheets I have. Okay, so that's where we are.
All right,
So
thank you.
let me start with this. And as I said, I just started to record this so that because I have at least 2 other people that hopefully will hop in. So I'm still looking for Patricia and Alicia. So we'll post this for them if they're not able to come tonight. Okay, so here we are at the introduction. And let me grab my notes so that I have them in front of me. There they are. Okay, so the first thing they start on in this chapter is talking about, data and functions in general, but they're talking about single variable data. So the word variables doesn't get to be used really in the younger grades. But you can kind of, sometimes they'll like put one ice cream cone plus another ice cream cone and they'll have those shapes. Those are your variables. So what you're going to be eventually bridging is to actually using like X's and Y's and stuff like that for variables. But you're actually using them in the lower levels too, which I'm sure you realize. So when you collect information, that's your variables are called the data. And there's 2 broad categories of data. It can be quantitative, which are all number data. If you're collecting height, foot size, shoe size, those kind of things, that's quantitative. Versus qualitative. How many kids do you have in class that are wearing a blue shirt today or that have, brown hair? Right, that's qualitative. So that's the 2 broad categories we have of data. A big part of the data is how you present it, because usually we collect data to gather information. So you're gathering information, which you're then going to share. So in order to share it, you have to kind of visualize how you would present it to whoever your audience is so that it's clear what the data is showing. So this is a good example of a nice visualization of a single variable data. So all this data is, it talks about educational attainment. It's from the year 2008, and it's for Americans 25 years or older. Okay, so it's not counting the kids that are in college currently. So what's their educational attainment? So down on the bottom is the educational level. Everything is labeled. So I want to also stress good data presentation. You've got to know what you're looking at. You have a title, that's key. You definitely want to have a title if you're presenting any kind of data. You need to know what it is, so it's educational levels. I can see that they have written all the different educational levels that they are collecting data on. Then you have two different y-axes. You have the one to the left that's telling you the number of Americans 25 years or older. So here's the number. Now notice these are in millions. Sometimes what they'll do, they will put the numbers 10, 20, 30, 40, 50, 60, 70, and then in parentheses, they'll tell you they're in millions. They didn't do that this time. They have the actual numbers, okay, which is kind of rare. You don't usually see that. And then on the other side is a percentage of Americans 25 years or older. So you've got all kinds of things going on. And the other thing you have to have your figure identified in a textbook, and you have to know the source. So all of that is there right with us so we can see it. So looking at this, if you were to estimate how many people do you see with bachelor degrees or higher? So if you talk about bachelor degrees or higher, so I would say that you are going to say, I need this one, I need this one, I need this one, and I need this one. So read the wording very carefully. This says bachelor degree or higher. It doesn't say higher than a bachelor degree. So that's why we're going to be including this column right here. So see what you get if you add up those columns. And I said estimate the number. I didn't say the percentage. So you need to read off of this. So take a second, see what you get. It'll be an approximation because you can't really read over on this grid very well. And this is in your textbook, but you can see it right here. So if you were to guess, it's going to be in the millions. So any takers? So the highest I have, I would say that that's what, about 38 million right there, just bachelor degrees alone. And then we're adding like another maybe 12. And then it gets really, really difficult to estimate the bottom two. They're about the same. They're definitely less than 5 million. They could be maybe 2.5 million. When I added it up, I got about 59 million. So know that that's the answer I'm looking for. I'm looking for the numbers, and you have to recognize with the wording which columns that you're adding. So I have 59, 0, 0, 0, 0, 0, 0. Okay, so then they want you now, so critical reading again, estimate the percent with bachelor degrees or higher. So there's an easy way and a hard way. Can anyone think of a quick way to do that? Because sometimes you want to work hard and sometimes you want to figure out what's a good way to approximate it. Does anybody have any ideas? Elizabeth, any ideas? You could just add them, right? But that's going to take you a little while. So what I did, I said, okay, I estimated 59 million. Let's say that was correct. Don't they have this nice little table over here that I can kind of line things up? So I can say if I'm about here, they're saying that 60 million is about 30%. So I'm saying maybe I'm a little bit under that. So I'm going to approximate it using the scale on the left, because I can do that since I added things up already. So I would say maybe, why don't we say like, I don't know, 29%, something like that. And I got that. I could have added up the percentages and try to figure it out. But what I did instead was lined up the number I got with the percentage that's on the right-hand side. And that gave me an approximation. And I think it's a pretty okay approximation. Okay, next one is estimate the number with bachelor degrees or less. So bachelor degrees or less, you've got to realize that you're again going to count bachelor degrees, but now you're going this way. So there's going to be quite a lot. So if you add up all of those, and I know it's hard, I think I tried to line it up. I got 173 million. Okay, so then what I did for the next one, it says estimate the percent with bachelor degrees or lower.
I got 90%.
You got 90%? Yeah, I got 87%, so that's good. So I would say let's put it at 87% to 90%. So you have to double count. So you can't just subtract 100 minus 29, because in here, it also includes the bachelor's degree. So that's what you want to be careful. Okay, they're including this column both times. So you have to account for that, and you can't do a quick thing and say, well, if there's 29% here, then there must be 71% on the other because I just did 100% minus 29%. You can't, because you have to double count. You have to double count because of that column. Okay, so then if you looked at this, there's always going to be information missing. So what's an obvious thing that's missing? There's a group of people that could be on this table as well, but they're not there. So who would they be? So look at who they're surveying. Who are they not surveying?
People less than 25, sorry.
Right, people under 25, right? People that they could have graduated college already, right? They could be in grad school for that matter. So they could be contributing to some of those columns, but they're not in the survey. So they're not in the survey probably for a couple of reasons. Maybe that's a transient group. Maybe they were harder to survey. So anyway, when you look at these kind of charts, you want to kind of be a detective with them. And this is important for kids of all ages, that if you have a chart like this, you want to know what you're looking at and what information you can conclude from it and what you cannot conclude from it. Okay, so those are the kind of things that you want to be thinking about. Oh yeah. Okay, so Christine has a good point. We have a live class on Halloween. Well, that seems awfully silly. I don't have any kids at home right now, but I'd probably be answering the doorbell all night long. So yeah, I'll make an adjustment there. Okay, thank you. So I have to make a note of that to myself. Yeah, and look and see if you say, okay, there's several of us that's our back to school night, that's our parent conferences, whatever, we can work all that out. So I will look at that. Thank you very much, because I had not looked with that in mind. So anyway, reading charts is going to be hugely important for kids no matter what level of school they're in. And it's important for adults. Read the newspaper, you have charts. What are they telling you? What assumptions are you making? And are those assumptions valid given the information that they had? What's your source? Is it a good source? So you want to be teaching that questioning behavior so that they have that skill set. Okay, so is anything else important here? So these are important things that graphs should have. Okay, so you can read that on your own, but we kind of hit a lot of good points there. So this is called a bar graph or a bar chart. Okay, bar charts have spaces in between the bars, as opposed to a histogram, which does not. So the next one is a histogram. So that histogram is a whole different thing. So this is US population age distribution. So this says under 5 years, this says 5 to 9 years, and so on and so on. so you have to figure out, what does that mean? Notice we only have numbers here. We don't have percentages, okay, so that's not there, but that's okay. We have a title, so that's good. We have the figure information, and we have a source, so all that's good. So now I want to know, how do you interpret the different histogram columns? So under 5, so I'm going to write this maybe sideways. Maybe I'll do it this way. So under 5 is clearly less than 5. Okay, so that's the first one. Look at the next one. This is 5 to 9. So you want to know that that means what happens is this. You put, I'm going to change my color to green. You put your variable in the middle. And if it says 5 to 9, then that's going to mean that it has to be greater than or equal to 5. And that's key, because your first column was less than 5. And then on the right-hand side, it's going to be less than 10. Okay, you have to know what they're talking about. So the way you do it, you put your variable in the center, and then you read it from the variable to the right and from the variable to the left. So that's x is less than 10. And simultaneously, x is greater than or equal to x. Okay, so that's what that means, because I cannot overlap. So then continuing, I'll do a couple of more just so you can see the pattern. So let's do this in brown. So the next one's going to be, I'm going to have 10 over here. It's going to be less than or equal. So x is greater than or equal to 10 and less than 15. Whoops, sorry, make that a 5. And less than 15. Okay, so you want to recognize what this means. So that was this blue one, because you can't have things overlap. And I'll tell you, this is the biggest problem people have, is knowing exactly what each of the columns mean. So that's what they mean. And that's why they're all smushed together with no space in between, because they run smack up to each other. Okay, that would be my dog. So that's the big thing about this column. Let me hang on one second. Let me just see what he's doing. I'll be right back. There you go. Good boy. Okay, I'm back. So histogram reading, you want to know how to do that. And then you can answer all kinds of questions about that. But since we kind of went through the other one in that way, I don't want to do it for this. So this also tells you, you always want to consider this information, what's important, have your titles, have all those good pieces of it. So if I tell you on a problem set to give me a table or a chart, you want to demonstrate these good characteristics. Have a title, have your units, have it be obvious what you are having on your table. Okay, don't leave it, don't do a random type table. Okay, so let's look a little bit into analysis of a histogram. So note that the bars are touching, and this should be in a histogram, while they are not in a bar chart. So you want to know the difference between these two. They mean two different things. And make sure you understand the intervals. We just went through that. So this is interval note. This is interval notation that we're going to be using for this. So, excuse me, that's mathematical notation. There's also interval notation, but I tend to use this in our class. So if I were to do this, the green one, in interval notation, what I would say is x has to be greater than or equal to 5. So it would be a bar there, a 5, and then comma, and then a 10, and then that would be a paren. Okay, that's interval notation. We tend to start using that in pre-calc. Okay, so we're going to use this mathematical notation down here. So we'll use mathematical, but I'm showing you interval. So that bar, that little bar right here, that little box, that means that the number in the interval can equal the number next to it. So it can equal a 5. But look, it can't equal 10. It has to be less than it, and that's why I use the parens. So in some textbooks, you'll see interval notation, and I just wanted you to have a good handle of it. Okay, so estimate number of people under age 20. So under age 20. So that means that you would estimate this one, plus this one, plus this one, plus this one. So it's going to be those four. So this, plus this, plus this, plus this. And when I did it, let's see what I got. I got about 84 million. So I got 84,500,000. 84,500,000. That's what I got just trying to read those four and add them together. 20, 40, 60, 80 plus a little bit. That looks about right. Then you want to answer these kind of questions. Which age interval contains the greatest number of people? So which bar is the maximum bar? So when you look at that, you want to kind of read across and what are you seeing? So if you were to be guessing, what would you say that was? So Angela, can you see that? It's probably going to be, which one do you think?
45 to 49 years.
Right. So it's going to be this one right here. That's the highest just by a little bit. So you can see that's kind of your early middle age, I guess. The numbers drop off down here clearly. We have a lot of very young people as well. So that's your peak at 45 to 49 years. So the age that's covered there is going to be, you put your X in the middle, and it's going to be less than 50, but greater than or equal to 45. That's the best way to represent those years. And then what's the smallest one? And it looks like it's going to be this one over here, 100 years and over. So that means that you would have just a one-sided notation. X has to be greater than or equal to 100. So that means the prior one would have gone to 99, and it does. Okay, so that's some notation you want to take heed of, and some interpretations and a distinction between the bar graph and a histogram. Okay, so that's some data presentation. Okay, so this one is not in your textbook, but I really like this one, and it gets used a lot. It gets used a lot in papers. It gets used a lot in children's textbooks because it's very visual. So what it doesn't tell you the absolute numbers. So this one just tells you the breakdown between the different uses of water. So how do we figure out what we have here? So 27.7%. So when they say percentage, do you know what the circle graph is based on? So if you have some number, okay, you have 360 degrees in a circle. So if you have 1/4 of a circle, that's going to give you 90 degrees. If you were testing 4 different things and they were each 90 degrees or 1/4 of the total, your circle graph would look like this. That's 90 degrees. So you would say each of those is 1/4. So this is a little bit different because you've got a lot more components. So if we knew how much water do we use in total in 1999, we'd be able to, based on these percentages, tell how much is used in each of the categories. But since we don't have that, all we have is relative percentages. We can only compare the uses. We can't identify what the total use is. Okay, so clearly the toilet is the highest, second to the clothes washer. Then you have shower, faucet. Look how high leaks are, 13.7% leaks. So we recently had a very little leak in our toilet. in one of the bathrooms in our house. It was unbelievable how much water can be lost in a leak. So I just couldn't believe it. And it was such a tiny little thing. It wasn't running. It was like dripping. And I had to put dye in the tank to figure out that it was actually doing it. But it was amazing. So I have a new appreciation for leaks. I would have been a little bit surprised about that percentage until that happened to us. And now I'm not surprised. And then you always have like an other category to take account of. So there's 5.3 in this other, whatever that might be. I can't imagine what that would be. Anybody have a thought of what that would be? Looks like everything's pretty much covered. So I don't know, but it's some other residential use that I cannot think of. So this is called a pie chart for obvious reasons. It looks like a pie. There are lots of fun things you can do with it. You can use the colors. You can, instead of using the colors, you can fill like the yellow for the toilet with little tiny toilets. You know, you can fill the shower one with little tiny showers. So it can be very, very visual for younger kids. And they'll get a good idea of how you demonstrate your data, how you show your data to people, because it's very, very engaging. You can cut it out. You can put it together. It's a very cool thing. And then it leads itself naturally into geometry. So these pie charts are really very good. I'm surprised it wasn't in our textbook because it is such a natural thing to talk about. And it covers such a wide range of grades that it would be interested to. And it leads, as I said, right to geometry. Okay, the next thing we're going to do is go through these measures of central tendency. So central tendency is a weird phrase, unless you realize that they're telling you that all these measure around the middle, around an average. So I know many of you probably know what these words are, but let's just to level the playing field, let's make sure we all know. So the mean itself is the average. Okay, mean is another way to write the average. The median is the middle number. Okay, and the mode, think about that O in mode, it's the number that appears most often. So these are ways to analyze data that don't involve the charts or the pie graphs we just saw. Okay, so measures of central tendency, it's a summary statistic that gives you an insight into what your data is telling you. Sometimes the average is the best. Sometimes the median is the best. The mode is not always the best way to represent your data. Median is the classic way of representing data that deals with real estate. They will often do median housing prices. And it's because the high prices skew the average so much that a median gives you a better idea of how the real estate industry is going. Okay, so mean is this formula. So this little symbol here is called X bar. So to get your mean, you would add up all your different numbers and then divide by the number you have. And we're going to do this on the calculator in just a little bit. So I want to show you how that works on that. So that is your mean. So if you're trying to average your test grades, you would add them all up, divide by the number of tests you have, and that's your average or your mean. So that's that. Okay, the median, in order to get it, let's say you have this data right here. That is not set up to see the median. What you have to first do is order these from smallest to greatest. Do that first, and then figure out, okay, what number of data points do I have? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 11 values. When you have an odd number, then the median is part of your data set. Because I have 5 values here, and I have 5 values here. So if you have an odd number in your sample, your median is always one of your data points. If you have an even number, and I think I have an even number here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 values here. Same procedure, put it in order. but I'm gonna have 5 values up to here, and then 5 values the rest of the way. Now, there's no clear median. So what our rule is, you take the 5th value, and in this case, the 6th value, so numbers on either side of the middle, and you add them together, divide by 2. So you're going to average them. So sometimes your median value in an even data set could be part of your data. That would only happen if this number and this number were the same. Okay, if they're the same and you add them together, divide by 2, you still get that back. So in that situation, your median value is part of your data set. More times than not, you don't have identical numbers on either side of the middle, and so your median value is not part of your data. It gives you information about your data, but it's not part of your data. Okay, so that's how it is in this case. The average would be 55.5, which gives me the median, but it's not part of this data, but it tells about the data. Okay, so is everyone okay about that? So that's how you have to sort it first. That's the key thing, and then look for the middle number. So the mode is the most often, and sometimes that's a good thing to get. Like if you give a test and the most frequently seen grade is like an 82, that's kind of interesting. How come everyone's getting 82s? Are they getting 82s and everyone's making the same kinds of mistakes? Because that's a good thing to kind of drill down on. Or are they 82s for random reasons? So sometimes a mode can give you some good information. Depending on where you're reading, you may have one mode data. Okay, that's a one mode data. Or sometimes they allow for 2 modes. If you have 2 modes, it's called bimodal data. And some will let you have 3 modes as well. But more times than not, when you get above 2, they will just say that your data is non-modal. So if you have greater than 2 modes, then really it's called non-modal data. And it just means that there's not 1 or 2 numbers that stand out as being the ones that occur most often. God bless you, Jessica. Okay, so that's how that all works. So here's another example. That's the mode right there. So another terminology for data, this is all data stuff, because we're talking about dealing with variables, and variables are ways to collect data. The range is always going to be your highest value minus your lowest value. So if I had, let's just go back for a sec up to this data here, my range would be 89 minus 14. So that's 575. Okay, 75 is my range. So it's always going to be a positive number, as long as you have positive numbers, I guess. But it's going to be the high minus the low. Okay, that's going to be your range. So that's another common term. Okay, so what I have now, I have these little practice masters, and I posted them online, but I believe I also have them on my iPad, so that I can show you that, and I can show you how to put it in the graphing calculator. So we're not going to do a whole lot because it's already almost 7. But I wanted you to see them so that it gives you some more time to kind of practice things. So let me just grab my keys so I can hit the high points. And then I want to show you the graphing calculator as well. Okay, so here they're doing some data, and that's all fine. We probably could talk about this, but you kind of get a sense of that data. Here's a bar graph. Here's an opportunity to make a circle graph if you wanted to. That's all there. Okay, so that's one thing. Let me go back. And then the other one I wanted to do is this one, because this is what I wanted to do with the graphing calculator so you can see it. So I have these values. They are data sets. And in order to get the mean, median, and mode, you could do it by hand, which is totally fine. And for these small sample sets, I probably would do it by hand. But let me show you how you could do it on the graphing calculator. So I have these numbers. I'm going to use these numbers. I have the numbers in front of me. In a second, I'm going to take the numbers away. If you want to just write down those numbers quickly, if you didn't print anything out, it's 11, 5, 8, 10, 11, 15, 7, 21. And I'll just show you how to input it into a calculator so that you can do this that way as well. So is everyone okay for me to stop share? I'm going to stop sharing here, and I'm going to come and pull up my graphing calculator. So let me go back down for a sec, and let me share this screen and go into the calculator. Okay, so this is a graphing calculator. And so when you use a graphing calculator, let me just move this thing out of the way. Okay, so when you use a graphing calculator, mine looks like this. This is the TI-84 Plus. The TI-84s, the TI-83s all have the same basic functionality. So what I want to do is I want to put the data that I had, the 11, 5, 8, etc., into my calculator. So what I'm going to do is I'm going to go into this key that says stat. When I hit the stat key, this comes up. So I now want to say edit. So I'm going to hit the edit. Let me see, I'm going to do that because I have to do it on the screen. So, okay, hold on. I need to move your pictures. Okay, so I want to get into the edit. So if I go to edit, so how am I going to do that? Okay, so hang on. I need to figure this out on the calculator. Oh, okay. So edit, I have numbers down here. So when I have my screen up, I want to go to number 1, and that's right here. So that gives me this screen. I'm going to put my data in L1 just the way I had it. So I'm going to start using the keyboard, and I'm going to type in the first line, the first horizontal line under L1, 11. Then I'm going to hit enter, and that puts it there for me. I'm now going to hit 5, hit enter. That's my next digit. Then I'm going to go to 8, hit enter, over to 10, hit enter. I have 11, enter, 15, enter, 7, enter, and 21, enter. You know, I just remembered back in the day, just several years ago, I had some students in my class who had access to the PARCC tests, and they had free graphing calculators on that as an online app. So there's lots of ways to get a graphing calculator. If you don't have access to one, talk to your principals because they may either have them or know how you can get access to them, so that you have it as well. Okay, so I'm just going to look, since all of your results are based on inputting this data correctly, I'm going to take a second and make sure that I didn't make a typing error because it's really easy to do that. And that's going to skew all your data. Okay, so I have the data in now. That's lovely. So now I'm going to go back to stat. Now that it's in, it's not going to go any place if I hit stat. I go back to stat, and I want to sort that data. I can sort it in ascending order, so that I would type in 2. And now they want to know what data I want to sort. Well, I want to sort my L1. So now we have to look and see where is L1. So on this graphing calculator, L1 is a blue button. So I say second, and I type 1. That tells it to sort L1. I close my parens, and I hit enter. And they say done, and then you can go back to stat and to edit, and there's your data nicely sorted. So that helps because I can kind of see, okay, what do I have? So I have 1, 2, 3, 4, 5, 6, 7, 8 data points. So what I know right away is that my median may not be part of my data set. I also can easily recognize my mode because that's the one thing that running a test on this or running calculations on this does not give you. Okay, so I can see the mode. I know that already. Once I sort it, that jumps out. But now I want to figure out other things. And I don't want to continue to do it by hand. So I'm going to go back into stat one more time. I'm going to go across the top and I'm going to go to calc. And I'm going to do one variable stats because I only have one variable in there. So I'm going to now hit, I went across the top to calc, it's highlighted, so I know I'm going to calculate something. I'm going to go in here to one variable stats and I'm going to hit 1. So here's 1. The default is L1, which is nice. So just always put your data in L1 because then you have one less thing to worry about because it's going to actually work on that list. So the list it's going to look at is the data in L1. I don't have a frequency list and I do want it to calculate it. So I'm going to hit enter, enter, and then it's going to highlight the calculator and I'm going to say, yes, please calculate for me. Here are all my stats. It's that fast. So here's your X bar. Remember the X bar notation? That's the mean. So I know that's 11. That also happens to be the mode, which is interesting. These are error terms. Here's the number in my sample. I have that right there. Here's my minimum. If I needed that, I have that. Here's my quadrant 1 value. If I wanted to look at quadrantal data, then I think I have to hit enter again to get the rest of it. No, I'm going to go down. I'm going to hit this and go down. Here's my median, 10.5, which makes sense because I had 211. I had 2 numbers that I had to average. So it's not part of my data set, but that's my median. Here's additional data that I don't need, my Q4. Here's my max, which I can verify that I have that max. Okay, so the one thing that I usually need for this class is the mode, which I don't see, but because I looked at my data when I was in my edit mode, I can give myself that answer. So that's how your calculator works. So that's what a graphing calculator will do for you. So if you can get a hold of one and practice doing some of these things, that would be really good. So those are the master's practices that we have. So I can do higher numbers. What else do we have? I could also do, I should show you one other thing. Let's do the frequency chart. So let me show you what that is on the handout. So I'm going to stop sharing here for a second. I'm going to go back into my iPad because it is kind of neat that you have the frequency options. So let me share my iPad again so I can share this. Okay. Okay. So down here it says Southtown Library conducted a survey to determine how many books teenagers read in a month. The results are shown below. Use this data for exercises 7 and 8. So what I wanted to do, I wanted to figure out a frequency chart. So I'm looking at the books and I want to figure out, okay, I'm going to go from low to high. How many times, let me just get a pencil. How many times is just one book read? So I'm looking, I have one book, it's read 2 times. So 2 times, only one book was read a month in the sample that they do to these teenagers. Okay, then the next number I'm coming to is 2. So the number is 2. Let's see the frequency of the 2 times a month. Here and here. So that's going to be 2 as well. Then I see a 3 out there. I see a couple of 3s. Here's a 3, and a 3. So 3 times people read 3 books a month. So 3 different teenagers read 3 books a month. Then for 4, I only have 1 teenager that's reporting 4 books a month. I have 1 teenager reporting 5 books a month and 1 reporting 6 books a month. So that's my frequency table. Now what I want to do is I'm going to use my calculator to input that data so that I can get all of this data back. So this is in lieu of having to add up all these numbers and then find averages that way and put all these numbers in order. You can put it in your calculator and there's a frequency aspect there as well. So I'm going to stop sharing here and go back over to my calculator. Oop, I have to say share first. Hang on one second. Share that and here. Okay, so here's the calculator. So I'm going to take this data that I have and I'm going to go up one. No, I don't want to do that. So let me clear that. Okay, so I want to get in my table. So how do I get in my table? Let me just think about this. Okay. So I would like to go up there. So I'm going to go to stat. I'm going to go to edit. I'm going to go up. Yes. And I'm going to say, so when I went up, I went back to stats and edit. I went up and that highlighted this box. When this is highlighted, you can hit clear and it looks like nothing happens. But if you come down, all that data is gone because it's kind of nice to use the L1. Don't hit delete because then you'll lose your L1. You can still fix that, and I'll show you that in a second, but hit the clear button to eliminate your data. So now what I want to do is I'm going to put the numbers that I just found in my L1 table. So I have a 1, I have a 2, and I'm going down the L1. Okay, so it's the same thing we did last time. I have a 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5. And it's much easier hitting the buttons on a calculator than on the laptop. 6. Okay, so that takes me to all my data. So I have everything in there. Now I'm going to go back up to the top and across, I went too far, across from the 1, I'm now going to use my L2 column to put in the frequencies. So that's going to be a 2. So I have a 2 there because there were 2 times that people read one book a month. And then there was 2 times that they read 2 books a month. So that's another 2. Then I have 3 for 3. And I believe I have 1 for everything else. 1, 1, 1. Okay, and that should be it. Yes, so that's it. So all my data is in. So my L1 is my data and my L2 are my frequency. So now I'm going to go back in here and I'm going to go back to stat. And I want to go, so if I lost my L1 because I hit delete instead of clear, you go to 5 and it'll restore it for you. Okay, that's an important button to know because you want to have the L1 because everything defaults to L1 and it just makes your life a little easier. So if you ever lose your L1, just go back to edit and hit number 5 and it'll restore it for you. Okay, so I want to go and I want to do some calculations. I am not doing one variable stats. Well, actually, I am doing one variable stats, but now I'm going to do a little bit different. So I'm going to hit enter for 1. But now I do have a frequency list. So my L1 is my list of my data, but then my frequency is an L2. So I have to go and look for L2, which is right above the 2 button, and it's in blue. So that means I hit the blue button and I go to L2. So that's there. So that's telling the calculator that I have this data in L1, but I really have, oh, sorry, I don't want to do that. I really have more than that. Let me just delete that little thing. I have data multiplied by that frequency list. So now come down and I'm going to say calculate. I'm going to hit enter. And then these stats are for all the combined data. Okay, it's not just the numbers 1, 2, 3, 4, 5, 6. It's those numbers multiplied. So again, you don't have a mode option, but I can look at that and I can see that the 3 is the mode. So now I see everything else. The average is the mode. Remember, X bar is your average. I have 10 in my sample size, and that sounds right. And my minimum is 1, which I know. Quartile 1 is 2, which we're not using, but here's my median is at 3. And I can find my max, so it's all good. So that's how you handle frequencies. And that comes in so handy when you have more complicated data. So that was 2 things I wanted to show you on the graphing calculator. Okay, so then there were other problems that I was going to do, but we may not do them. Let me just see how far I wanted to get. I wanted to finish this next little section, which is considerably shorter than the one we just did. So let me look at that. Okay, so let me just stop sharing for a second. So we've done this, and we've done that, and we've done that. So I had some things in the textbook. So questions I would tell you to look at. In the textbook, I don't know if I wrote that down any place for you. Let me tell you. In 1.1, I would look at 2, 4, 6, 8, 10, 16, 20. So that's in 1.1. Then I really thought they had great algebra aerobics, which is another page. On the algebra aerobics, they had 2, 4, 6, and 8. And they were really interesting questions. So just kind of peek at those in light of what I just taught, see if that makes sense to you. So then what we can do pretty quickly is look at this next little section, which is 1, 2. So I'm in the same packet that I posted, but now I'm going to talk about the 1, 2 stuff, which talks about describing relationship between 2 variables. Because up to this point, we had just 1 variable. So I'm going to share screen again. Anybody need to take a quick bathroom break or get some water? So always yell at me because I tend to. So I'm not originally from Maryland. Clearly, I'm from New York because of my accent. So I tend to sometimes go really fast. So feel free to, just either message me or say slow down, and that's fine. Because I don't know your total knowledge base, and I don't want to go too fast or too slow. So I'm trying to hit a good speed. Just let me know if you need me to do any kind of adjustment. Okay, let me share screen again. So I'm going to go back into the notes that I was doing. Okay, so okay, so I was thinking about switching over. Yes. Okay, so this is good. Okay, so that's where we were a second ago. Let's go back into the notes. So we were here. So we did this. So now this is 1.2. It's describing relationship between variables. So in this situation, you have year and median age. So you don't just have 1 variable, you have 2. So when you plot that, this is called a time series plot. And what they tend to do is you put the year on the x-axis. Okay, the y is the dependent. So let's write that down. The x is the independent axis. So time marches on, right? Time waits for no man. We've got all those expressions because time is driving the train. Whatever is the independent variable, which is usually your x variable too, that goes on the horizontal axis. This is your y variable, which is your dependent variable. And the dependent variable is impacted by time. So as time goes on, the median age of the US population seems to go up. Okay, so Y is dependent, X is independent. X is driving the train. So one thing they talk about, I think in the textbook, and I've seen in other textbooks also, what are some things you can say about this data? So what would be your 60-second summary? So, and that's an important thing with kids too, of any ages. If you look at this and you say, tell me a couple of things that you notice about it. So tell me something you've noticed. So just call out. So Elizabeth, tell me one thing that you noticed on this data.
That it increases until 1970 when you have a little bit of a dip,
Okay, good.
and
It's
then it increases again.
good. So you did some analysis of that as well. Okay, Angela, throw something else at us. What else do you see?
There also seems to be a slight dip just before 2010.
Yep, yeah, right there. Just very, very slight. But yes, it does. It does. Okay, Annie, what else do you have? It can even be, is it titled correctly? Is the title present? Do I have a source? What is the source? Like all those things could be part of a 60-second snapshot. So is it always actual data? Because look down here. This is actually projected here. All right, so maybe this data is not as reliable, and that could be an observation. Does that make sense? Whose little hand do you have there? Your very cute little hand.
My 5 months old, sorry, I'm breastfeeding right
That's
now.
okay. Looks like she really likes math. So okay. I know, so cute, so cute. Okay, Tristina, you still there? You want to comment on anything else with this data? I think she may have stepped away. So with all of this data, no matter how you present it to your kids, no matter how little they are, it's good for them to start being reflective and analyzing things. So notice it's not the mean age, it's the median age. So that means it's the middle numbers. So that's kind of interesting. I wonder why they did that. It's not the world population, it's the US population. So, and why were these little dips? Why are these things happening? What could be happening economically? So I'm surprised that between 1940 and 1950, I guess the median age is up, and that would make sense. But now you have a little dip. So why do you think you have that little dip? What would you say? This is in the baby boomer years, right? So if you're in the baby boomer years, then you're getting more young people, more little nurslings, and that's going to drop your median age. So you can do a lot of interpretation about this, and you can kind of see a lot in the data, because when you get used to doing that, you kind of are more open to interpreting things that are perhaps a little bit more complicated. So that's, let me just get this back up. So that's what that is, what you want to do with that. Okay, so then I have something else for you. So far, we've just used data. Now they're going to use equations to convey information. So what you have to recognize is that your E, okay, so this E is here. That's based on your y-axis, okay? This is your y-intercept, This 6250 is your slope, and this, the N, is your independent variable. Okay, so basically it's a line, and it has the equation y equals mx plus b. So the y is the vertical axis, the x is the horizontal. The M stands for, it's French for mont, mountain, slope. Okay, the B is your y-intercept. It's where it crosses the y-axis. Now, interesting enough, it's 1,140. So if you look at this, there's no way in the world you can read that, because you can't see 1,140. Okay, and that's because your first value here is so much greater. So it appears that your y-intercept is 0, but it is not. Okay, so here's an appearance of one thing, but the reality is really what the equation's telling you. And this 1140 is actually where the graph crosses the y-axis. Okay, so a little thing about slope. Okay, so once you have an equation, you have a relationship, and the relationship allows you to extrapolate. You can say, okay, what if I try to go past year 16? I could just plug in right here where I have my n, plug in a 20 there, and you can get an approximation about what your E is going to be. Okay, your y-intercept's going to stay the same. The slope you're going to assume is staying the same, but you can generate more extrapolations of data by using the equation. Okay, and that's a simple equation. It's a line. Okay, other things. Here's another line. So here's an equation. Excuse me, this is not a line. This is another types of equations. This is called a quadratic function. So that's one name for it. Because it's used so many different ways, it has lots of names. You can also, okay, this is when you graph it. You can also call it a parabola. The way it's different from a line, so I'll put a line right here. Your line is y equals mx plus b. Okay? The line that we saw on this previous page had a positive slope. It was going up, positive slope. If you have a positive slope, that function is always increasing. The numbers are always getting bigger on the y-axis as you progress to the right on the x-axis. As opposed to a quadratic. Here's your basic quadratic function. What's happening here, and I'll highlight. So here, all the way down to just about here, your function is decreasing. Your y values are getting smaller and smaller. But then when you turn the corner, your function is increasing. So you can have two things happening on a parabola. With a line, only one thing can happen. So think about this. When you see that squared, so here's a little square term up here, that 2, that tells you that two things can happen. You're going to be decreasing and increasing, and that's what it looks like. So there's a lot of math involved in this, and you may need to read this in the textbook as well. So if they give you this equation, okay, so the equation they gave you is for this graph. It's y equals x squared plus 2x minus 3. And they want to know are 1, 0 and 0, 1 solutions. And so what you're going to do is, to see if those are solutions, you can do a couple of things. So solutions mean if I plug in this x and y in my equation, is it going to be a true statement? So let's test the first one. So if I test the first one, I'll do the first one in pink. I want to know what y equals. So y has to be 0 according to that first coordinate pair. So 0 has to equal, and my x is 1 squared plus 2 times 1 minus 3. So that's 1 plus 2 minus 3, and that does indeed equal 0. So now I know that this point is on that graph, because when I plugged in the x and the y, it made for a true statement. Try the other one. I'm going to do it in green. We're going to use this one instead. And by the way, where is that point 1, 0? So that point there, these go by 2s. That point is right there. So I should have done that in red. Let me just write over that. That's your red we just tested. Okay, what about 0, 1? Is that a solution? So we're going to try that, and I'll do that in green, and I'll do it down here. So if I'm going to test it, my y has to be 1. 1 has to equal 0 squared, which is just 0, plus 2 times the 0 minus 3. So everything falls away except the minus 3. That does not make for a true statement, so this is not on it. Okay, so how many solutions are there? So the solutions are the points that work. So I believe it's going to be an infinite number, right? Because you can have an infinite number of points all here. You can just make them super, super small increments, but you can get an infinite number. This is called a t-table, and that's a way of testing things out. So you pick your x and see what y you generate, okay, using the equation. That will let you plot out that parabola. Okay, so where one solution of infinitely many solutions is labeled. Okay, so here's one solution of an infinite number, because there was an infinite number of solutions. So here's your table. I call it a t-table. You can use technology to graph the equation. So why don't I show you that real fast? And then is there anything else? Yeah, let me hold off on that. I want to show you how to graph this because that's kind of cool. So we'll come back to that in a second. Let me just finish the notes, and then we'll finish with the graphing, and then we'll be done. So I don't want to hold you over. Okay, so other things, solutions for equations in 1 or 2 variables. Describe how the solutions for the following equations are similar and how they are different. Okay, look at this one. This is a line. So you can have certain numbers that will work, certain other ones will not work. Okay, look at this next one. X plus 2 equals X plus 2. Well, it's going to work for an infinite number because whatever you put in on one side, you've got to put it on the other side because you're defining the variable the same way. Okay, and you could kind of do the same thing. So there's an infinite number of solutions for the second one. There's only one solution. When X is 2, you're only going to get one answer for the first one. And there's also an infinite number of solutions for the last one. Okay, so only this one is going to limit you to a solution path. This is a little ellipse. It has its own equation. You would do the same thing with your variables that you pick to figure out if it's going to make this true. Okay, so that's all that they're doing is they're showing you, here's an equation. Tell me what's the solution to it. So you can pick something. So if this is 3, my guess is that 2, this is 2, 0. And this is negative 2, 0. That's going to work. This is 0, 1. And this is 0, negative 1. I have found 4 solutions just looking at this little figure that I know will work in that equation. Okay, so then they say, here's the problem in the textbook, and they have you analyze this as well. But let's finish off with the calculator because I think the calculator is such a great resource that I want to show you another thing that you can do with it. So we're gonna plot a line and a quadratic, and then we're gonna call it a day. So let me stop sharing here. Let me go back into the calculator. And so I'm going to share screen and get my calculator. And there's a magic window over here. Okay, it's called the y equals. So I'm going into the y equals. In the y equals, let's plot a line. So what if I say my line is 5? Here's where my x's lie, right here. 5x plus 1. Okay, the slope is 5. The y-intercept is 1. I want to graph it. I'm going to go to my window first and see what it's set up as. Okay, that's a standard window. I'm going to now go in and say graph. There's the line. So look what I have. Here's my y-intercept. To get to the next point, I'm going to go up 5. 1, 2, 3, 4, 5 over 1. That's using my slope to plot it out. That's my line. So where I put it was in the y equals. This is a linear equation. It's a line. Let's use the next spot, which is the y2, to plot that parabola. Your x lives here. So you hit your X. I'm going to square that X. Then I'm going to say plus 2X. And then I'm going to say minus 3. Okay, that's the graph we just talked about in the notes. So I'm going to, let's see what I'm going to do. I'm going to come up here and I'm going to come to the equal sign and I'm going to hit enter. And I'm going to move off the equal sign. That turns off that equation. So when I hit graph, I'm only graphing the parabola. Okay, so there's my parabola. I can see where the vertex is. Down here is the lowest point. I can see where it intercepts the x-axis. I can see where it intercepts the y-axis. I have plotted my parabola. Let's say I'm curious what the table looks like that I could use to plot that. You can go into second graph to get the blue table. And here is your little t-table all set up for you. So this graphing calculator is a miracle. Because when I was in school, way back in the day, we didn't have graphing calculators. Everything was totally by hand. And you can see so much more using a calculator in terms of making generalizations. I'm not saying use it for addition and subtracting, but when you want to see patterns, it's great. The other thing I can do is this. I can turn that top one back on by coming over one, putting over the equal sign, hit enter, and now look what I can do. I can graph both of them. I can find that these two graphs intersect right here. And I could use my calculator to figure out where that intersection is. So it's a great tool for seeing these kind of patterns and relationships. So I'm gonna use it a lot in the course, and I'll show you things. A lot of the course you perhaps could do by hand, but I think it'll be more valuable to you if you can use some of the technology. Okay, so that's all I have for you tonight. Hopefully you're not going to run and put your head in the oven and drop the course, but it's a lot of material. Depending on where you are in math, it could be a lot of new material or a lot of review material. So what I would do is go over that notes. I would read in the textbook a little bit. I would try to look at the problem set. See what we covered so far. See what you could do on it and what you might have questions on. Okay, and then during this week, if you know you have questions and you want to chat, shoot me a message. If I get a couple of people, I'll say, okay, let's see if we can hop on another time and go through some of this stuff, okay? So I can do that with you as well, because I want to have this all be a valuable course for each of you, no matter where you're coming in from. Okay, so you survived the first one. That's excellent. So we'll be on Zoom next week, unless we decide that we want to do something different. I'm going to stop the recording now.